Every day, millions of beer bottles are thrown away, shattered, forgotten, or buried under piles of waste. But what if those broken fragments were not the end of the story? What if every discarded bottle carried the potential to be reborn, not once, but endlessly? Today, we step inside the powerful industrial process that transforms broken beer bottles into brand new glass containers, proving that glass is one of the few materials on Earth that can be recycled forever without losing its purity or strength. The journey begins long before the furnace ignites. Used beer bottles are collected from restaurants, supermarkets, recycling bins, and industrial waste centers. Once transported to the recycling facility, the bottles move onto massive conveyor belts, where advanced sorting systems begin their work. Magnets remove metal caps, air jets separate lightweight contaminants, and optical scanners identify and divide the glass by color. Clear, green, and brown glass must remain separated because even small color contamination can affect the quality of the final product. This careful preparation ensures that the recycled glass maintains the same standard as newly manufactured glass. Before the glass can be crushed or melted, it passes through a stage where human precision becomes irreplaceable. Along long conveyor belts, workers stand side by side, carefully inspecting every bottle that moves past them. Their trained eyes instantly recognize differences in color, shape, thickness, and contamination. Some bottles still carry labels soaked in liquid. Others contain small stones, plastic pieces, or foreign materials that machines might overlook. With swift and practiced movements, workers remove unwanted items, separating brown, green, and clear glass into designated streams. Machines assist in the background. Magnets pull away metal caps, and air blowers remove lighter debris. But it is human judgment that makes the final decision. In this moment, recycling is not just an industrial process. It is skilled labor combined with experience. This careful manual sorting ensures that only clean, properly separated glass continues forward, protecting the quality of the new bottles that will soon be formed. After sorting, the bottles are fed into industrial crushers where they are shattered into small uniform pieces known as cullet. The sound is sharp and relentless as tons of solid glass break down into fragments. These pieces are then cleaned again to remove any remaining impurities. Cullet is extremely valuable in glass manufacturing because it melts at a lower temperature than raw materials like sand, soda ash, and limestone. The more cullet used, the less energy required, reducing both production costs and carbon emissions. Once the bottles have been crushed into cullet and carefully cleaned, the journey is far from over. The small glass fragments are transported through an automated material handling system designed for both efficiency and precision. Conveyor belts carry the cullet upward into elevated storage silos, where it is temporarily held and measured. From there, controlled feeder systems regulate the exact amount of recycled glass entering the furnace. Every kilogram is monitored to maintain the perfect balance between cullet and raw materials such as silica sand and soda ash. Dust extraction units operate continuously to prevent fine particles from escaping into the air, ensuring both environmental safety and worker protection. What may appear to be a simple transfer of broken glass is in fact a highly controlled operation. The consistency of this feeding process directly affects melting stability, temperature control, and ultimately the structural quality of the new bottles that will be formed. The purified cullet is transported into a massive furnace operating at temperatures approaching 1,500 degrees Celsius. Inside, the crushed glass slowly transforms into a glowing, molten liquid, radiating intense heat and light. At this stage, chemistry takes over. The molecular structure resets, eliminating any trace of its previous form. Whether the glass once held beer, soda, or water no longer matters. It becomes pure molten glass again, indistinguishable from newly produced material. This is the moment of true transformation. From the furnace, the molten glass flows into a forming machine where it is precisely cut into measured portions. Each glowing portion drops into a metal mold, and compressed air shapes it into the familiar form of a bottle. The shaping process happens within seconds but requires extreme precision to ensure uniform thickness and structural strength. The once broken beer bottle is now taking shape again, smooth, symmetrical, and ready to serve its purpose once more. After the bottles are formed, but while they are still hot, they pass through an important yet often overlooked stage: surface treatment. At this point, the glass may look complete, but its durability is not yet optimized. A thin layer of protective coating is applied to the outer surface to strengthen resistance against scratches and impacts during transportation. In many factories, a hot-end coating made of tin oxide is first sprayed onto the bottle surface while the glass remains at high temperature. This microscopic layer bonds with the glass, increasing its mechanical strength. Later, a cold-end coating is applied after partial cooling, reducing friction between bottles as they move along high-speed conveyor lines. These invisible treatments dramatically improve durability, ensuring that the bottle can survive filling, capping, packaging, and long-distance shipping without damage. What appears to be a simple glass container is, in fact, engineered for resilience at every stage. Newly formed bottles are not immediately ready for use. They must pass through an annealing oven where they cool gradually in a controlled environment. This slow cooling process relieves internal stress and strengthens the glass structure. Afterward, advanced inspection systems scan each bottle for microscopic cracks, air bubbles, or deformities. High-speed cameras and sensors ensure that only flawless bottles move forward to packaging and distribution. In the end, what was once discarded as waste returns to the market as a brand new glass bottle, identical in quality and strength to the original. Unlike plastic, glass does not degrade when recycled. It can be melted, reshaped, and reborn endlessly. The next time you hold a beer bottle in your hand, remember, it may have lived many lives before, and it is ready to live many more. But the story does not end when the bottle leaves the factory. Every recycled glass bottle represents more than just industrial efficiency. It represents energy saved, raw materials preserved, and emissions reduced. Using recycled cullet significantly lowers the temperature required for melting, which means less fuel consumption and fewer carbon emissions released into the atmosphere. For every ton of glass recycled, valuable natural resources like sand and limestone are conserved. Unlike plastic, glass does not degrade in quality after recycling. It can be melted and reshaped endlessly, forming a true closed-loop system. This makes glass one of the most sustainable packaging materials in modern industry. What seems like a simple bottle on a shelf is actually part of a continuous cycle, a system designed to reduce waste and protect the planet.